Hello, this is my presentation to the stakeholders in pursuance of DAT 690, the Capstone project. This presentation will be looking at a potential way for General Electric to reduce employee attrition rate by using a predictive model. I understand that we have representatives from the Analytic department, HR, and development here today. I will do my best to meet everyone's needs as we move forward. Hi, my name is Beverly Gagnon, and I'm a student at Southern New Hampshire University studying for my master's in data analytics. I'm in my third year, and here's my email address in case you have any questions or feedback that come up after this presentation. First off, I will be covering the why of this project. I'll talk about the pilot that was put together as a mock version of this final project. I'll also touch on the changes or modifications that needed to be made from the first attempt at this project. I'll report the results of the models made to reduce the attrition rate at GE, bringing up conclusions that were recognized or should be addressed when working with the present model, and lastly, some recommendations the model could be used for in the future to help grow and maintain success for General Electric. According to our friends at Reuters, General Electric Company is a worldwide digital engineering company. GE's products and services extend from power generation, aircraft engines, and oil and gas production equipment to industrial, medical imaging, and financing products. GE is so large and diverse, it demands the greatest employees and low attrition to run effectively. The data set that we will be using is the employee attrition data set that was given to us by your own HR department at GE. The data set includes 1,470 present and past employees of GE, with 35 variables pertaining to their positions here at GE. Simple things like their age, gender, education, years at the company, whether they have overtime, or what their performance records are. Names and personal information like location are not included in the initial data set, so there is no need to worry about your information being known. All employees are anonymous. The problem statement for this project is, what is the likelihood of employee attrition with a GE? What are we missing? What can be improved? How can we predict which employees will be affected? This project can seek out some variables that could be the causes of employee attrition. We can explore the data and find out which of the job roles are more likely to seek employment somewhere else. Knowing in advance, GE could make steps in retaining their biggest assets, their fully trained and seasoned staff. Also, where can GE focus on for some kind of an incentive plan to keep their employees, thus retaining their staff? The two types of research methods being used for this project are descriptive and predictive analytics. Descriptive analytics can usually be done quickly in Excel or another data program, resulting in bar charts, pie diagrams, or histograms. They can be produced to show relationships within the data set. For example, how much fruit costs in Japan, or how often does it rain in the month of May? This is called exploring the data. Predictive analytics is taking the data set and loading it into a predictive model and having the program or model tell the story of what will happen next, sort of like the patterns that exist when employee attrition is present. Now, why would we want to do this? Well, the Human Resources Department in GE has recently become aware that many high potential employees have left the company to pursue other opportunities. This awareness was raised by many middle managers and support by their recent increase in job postings. Within the need to remain competitive and the total cost and time required to train new employees, the need is present to identify how talent may be retained within GE. Even keeping a fraction of the employees that are quitting could lessen the money's loss because of employee attrition. Our first attempt at exploring the data and building a predictive model was a mock version of this project. Our company first looked at the data, Notice there was no missing values, so it would be in the right state to be loaded into our predictive tool and start exploring the data and building models. Sounds great, right? Well, we're missing something. Way back in 1996, our standard process for data mining was invented. It was called Cross-Industry Standard Process for Data Mining, also known as CRISP-DM. This process has 6 components: business understanding, data understanding, data preparation, modeling, evaluation, and deployment. These steps are pretty self-explanatory, but are sometimes missed and the data project is unfinished or crippled in a way that does not tell the whole story, or the data scientists are not working with the correct information. During this presentation, we'll go through the steps of CRISP-DM and point out how important every step is in the data mining process. In this graphic, you can see how all the steps depend on each other in order to have a successful project. We have already gone over the business understanding step. I know I went over this briefly earlier, but let's dive into it a little deeper. Predictive analytics describes historical trends, predict outcomes, or suggest direction based on large data sets. The outcomes are based upon statistical algorithms that can see possibilities that might otherwise be lost. Predictive models use existing data to assist leadership in decision making. Predictive models can predict whether some attributes will behave in a certain way, like whether a person is at risk for quitting GE. For the next few minutes, I will give you some perspective on our proposal, explain the technical specifications of the methods used, highlight our discoveries, and talk about the future direction of the model. Our first pilot plan we created for this project will include some predictive analytic models, including the decision tree and random forest models. Both models use the variables and seek out the predictive plan by looking for patterns. The first step that was taken in our pilot plan was data preparation. The data prep was done minimally. It was manually done in Excel, and we noticed there was not any missing data, so the team loaded it right into Rattle. Without exploring the data, the model building started. The decision tree is a prediction model that uses target variables to make its predictions. It works on learned decision rules. We created 2 decision trees. Both used a different number of variables and the depths were different. One was 5 and the other one had a depth of 3. The second tree seemed to show some promise. The preliminary decision tree with 5 for split and a bucket of 3 as a maximum depth shows overtime as being a top variable for employee attrition, followed by age and job role. The tree was kept small to give something to show for its effort. Keep it simple. The ROC curve, ROC standing for Receiving Operating Characteristics, shows 70% accuracy rate for the decision tree from the previous slide. The ROC curve is a way to evaluate the validity of a predictive model. That's impressive for just one decision tree on its own. But could another model do better? Another type of predictive model is a random forest model. A random forest model is a number of decision trees that are grouped together to work as one unit to come out with one predictive variable. Thirdly, we made 2 random forest models with 500 trees and 5 variables. It too put overtime at the top of the list, along with age and job role as its top variables. Are we seeing a pattern yet? The ROC curve for the random forest model I just spoke about is showing an 85% accuracy rate. So those variables might be the factors to show some attention to through GE employees. This, of course, is just the tip of the iceberg of the work that is needed to completely nail down the answer to our problem statement of what is the likelihood of employee attrition at GE. Being able to find the variables that keep your employees in their positions, GE can save money on recruitment to replace the employees that leave. It can save money on training new employees and from the first 2 factors by not losing the employee in the first place. Finding a new employee and training them could cost up to 1 to 2 years' salary of the executive that just voluntarily left. How can this data mining project produce better? To answer this question, a think tank team was assembled to hash out where we can make modifications on our data mining project to streamline the process and make a model that can be used for this project and others in the future. As a review, during our mock data mining project, the data was not touched once we realized that no data was missing. The data was loaded into our programs and modeling started. Models were made with the hope that we might get it right without knowing too much about the data set that was being used. One change we made was to alter what was done to the data. We seemed to skip the data prep stage from the crisp DM process. We needed to delete the variables that did not impact the model's outcome. We took out variables like hours worked, employee number, under 18, among others. Most of these variables were repetitive and needless to our project. The stripped down dataset was loaded into Rattle, which is our modeling program. We explored the data because of the feedback that was given from our think team to see if there was a particular job role that would have the likelihood of attrition. Also, the goal was made to have only one model that works with the data set. Just one with a high accuracy rate, ranks low with an error rate, and is reproducible. Our team fashioned a data prep flowchart with steps to follow to use when preparing data. This had to be thorough because this was the step that was missed in our mock project. It checks if the data is in the correct format for the tool being used for modeling, whether the data is relevant to the project, checking to see if numbers are real values or just representing something like 1 equal to true and 2 equal to false. And then finally, the step of loading the data set into the tool being used for the project. This time around, the team decided to explore the data in Rattle. We discovered that lab technician seems to be the job role that is likely to leave their position voluntarily, followed by sales executive. This was the information we did not know the first time around in the mock project. With the knowledge we had in hand and the stripped down data set, we created and followed this flowchart to build the model needed. During the mock project, the random forest seemed to be the predictive model that performed best. The random forest model was the first thing we tried. We tried a few times with different numbers of variables. We were able to cut it down to 5 variables, and this is what happened. Our model had an overall error rate less than 20%. That is almost an 80% accuracy rate. The ROC curve also validates the model with an 81% accuracy rate, which is indicated by the red line. In the performance chart, the precision line, represented by the dashed red one, shows an error rate of 20%, and the recall line, the blue dashed line, is giving an accuracy rate of 84%. That's a great outcome. A great performing model, too. It mirrors the information that we already know and did a great job showing validation in this visualization. And lastly, we were able to reproduce code for the random forest model that could be used for future data projects needed by General Electric. We had 2 conclusions that revealed themselves within the dataset given to us from Human Resources, which are, we have an 84% accuracy rate of our model. The job role that is most likely to leave are lab technicians who work overtime. This model could be used in another data mining project. The work that was produced by this project is priceless because this project can have the return of investment in 1 year of 3 lost lab technicians. Knowing this in advance, GE can make plans to retain their staff, save money on job postings and training, and keep their employees. Some future projects GE can use this random forest model are pulled from other projects from Fortune 500 companies that have used them before. Projects to help with customer trends, marketing and advertising. Projects like this improve daily operations and foresee sales for future quarters or years for the company. I want to thank you for your attention and time for this presentation. I hope you found it informative. It was an interesting and eye-opening project for us. Are there any questions? Remember, you can find me at beverly.gagnon@snhu.edu. A copy of this presentation has been emailed to you by your supervisor. If you have any questions that come up, feel free to email me. Thank you again, and I hope to work with you on this project.